Hello, welcome to Cloud Learning channel. In this module, we will talk about Snowflake table structures. In this module, I will talk about topics including understanding Snowflake table structures, micro-partitions and data clustering, clustering keys and cluster tables. We will also talk about benefits of the cluster tables. And also we'll talk about automatic clustering, manual reclustering, and we will talk about the tables, temporary tables, transient tables, and actional tables. Let's start with understanding Snowflake table structures. Understand Snowflake table structures. All data in Snowflake is stored in database tables, logically structured as collections of columns and rows. To best utilize Snowflake tables, particularly large tables, it is helpful to have an understanding of the physical structure behind the logical structure. So all these topics describe micro-partitions and data clustering, and two of the principal concepts utilized in Snowflake physical table structures. So as I mentioned, so the two topics describe micro-partitions and data clustering. So these are main concepts utilized in Snowflake table structures. And they also provides guidance for explicitly defining clustering keys for very large tables to help optimize table maintenance and query performance. In the next slides, we will talk about micro-partitions and data clustering, and also we will talk about benefits, like why these two are principal concepts utilized in Snowflake table structures. So we will talk about the next one. What are micro-partitions? Traditional data warehouses rely on static partitioning of large tables to achieve acceptable performance and enable better scaling. In these systems, a partition is a unit of management that is manipulated independently using specialized DDL and syntax. So, however, a static partitioning has a number of well-known limitations such as maintenance overhead and data skew, which can result in disproportionately sized partitions. So in contrast to a data warehouse, the Snowflake data platform implements a powerful and unique form of partitioning called micro-partitioning that delivers all the advantages of static partitioning without the known limitations, as well as providing additional significant benefits. So all data in Snowflake tables is automatically divided into micro-partitions, and which are contiguous units of storage. So each micro-partition contains between 50 MB and 500 MB of uncompressed data. And let's remember, the actual size in Snowflake is smaller because data is always stored compressed. So groups of rows in tables are mapped into individual micro-partitions organized in a columnar fashion. So this size and structure allows for extremely granular pruning of very large tables, which can be comprised of millions or even hundreds of millions of micro-partitions. Snowflake stores metadata about all rows stored in a micro-partition that includes the range of values for each of the columns in the micro-partitions, the number of distinct values, additional properties used for both optimization and efficient query processing. What are the benefits of micro-partitioning? So as I mentioned, micro-partitioning is automatically performed on all Snowflake tables. So tables are transparently partitioned using the ordering of data as it is inserted or loaded. So let's talk about the benefits of Snowflake's approach to partitioning table data include, in contrast to traditional static partitioning, Snowflake micro-partitions are derived automatically. So they don't need to be explicitly defined upfront or maintained by users. It automatically derived. As the name suggests, micro-partitions are small in size. And it could be like, it is a 50 to 500 MB before compression, which enables extremely efficient DML and fine-grained pruning for faster queries. And also micro-partitions can overlap in their range of values, which combined with their uniformly small size helps prevent skew. Columns are stored independently within micro-partitions, often referred to as columnar storage. So this enables efficient scanning of individual columns, only the columns referenced by a query are scanned. Columns are also compressed individually with micro-partition. Snowflake automatically determines the most efficient compression algorithm for the columns in each micro-partition. Let's talk about data clustering. Typically, data stored in tables is sorted or ordered along natural dimensions, example, date or geographic regions. So this clustering is a key factor in queries because table data that is not sorted or is only partially sorted may impact query performance, particularly on very large tables. In Snowflake, as data is inserted or loaded into a table, clustering metadata is collected and recorded for each micro-partition created during the process. Snowflake then leverages this clustering information to avoid unnecessary scanning of micro-partitions during querying, significantly accelerating the performance of queries that reference these columns. What is a clustering key? In general, Snowflake produces well-clustered data in tables. However, over the time, particularly as DML occurs on huge tables, um, the data in some table rows might no longer cluster optimally on desired dimensions. To improve the clustering of the underlying table micro-partitions, we can always manually sort rows on key table columns and reinsert them into the table. However, performing these tasks could be cumbersome and expensive. Instead, Snowflake supports automating these tasks by designating one or more table columns expressions as a clustering key for the table. A table with a clustering key defined is considered to be clustered. And what is a clustering key? A clustering key is a subset of columns in a table that are explicitly designated to collocate the data in the table in the same micro-partition. This is useful for very large tables where the ordering was not ideal or extensive DML has caused the table's natural clustering to degrade. So some general indicators that can help determine whether to define a clustering key for a table. Those are the indicators are queries on the table are running slower than expected or have noticeably degraded over time. And also the clustering depth for the table is large. A clustering key can be defined at table creation or afterward. Let's say if you forget to, if you want to define a clustering key, you can define it while creating table. Or if you create it and then you forgot to define a clustering key, then you can define it again by just using alter table. We will talk about that in next slide. So the clustering key for a table can also be altered or dropped at any time. So if you don't want the clustering key, you can drop it. You can drop that from the table. And let's talk about benefits of defining clustering key. Using a clustering key to collocate similar rows in the same micro-partitions enable a lot of benefits for very huge tables. That including improved scan efficiency in queries by skipping the data that does not match filtering predicates. And the second one, better column compression than in tables with no clustering. So this is especially true when other columns are strongly correlated with the columns that comprise the clustering key. And the other benefit is after a key has been defined on a table, no additional administration is required unless we choose to drop or modify the key. Like I mentioned, if you want to drop it, clustering key after defining, you can drop it by just using alter table, or you can create it using create table. And all future maintenance on the rows in the table is performed automatically by Snowflake, and we don't have to worry about the maintenance of these tables. Although clustering can be substantially improve the performance and reduce the cost of some queries, the compute resources used to perform clustering consume credits. So as such, we should cluster only when queries will benefit substantially from the clustering. So consideration for choosing clustering for a table. Whether we want faster response times or lower overall cost, clustering is the best for a table that meets all of these criteria. So one criteria, the table contains the table contains a large number of micro-partitions. Typically, this means that the table contains multiple terabytes of data. And then what is the second scenario? The queries can take advantage of clustering. Typically, it means that one or both of the following are true in here in this second scenario. You can see second criteria. The queries are selective. In other words, the queries need to read only a small percentage of rows in the table. And the second one is the queries sort the data. Example, the query contains an order by class on the table. And what is the other criteria we're talking here? A high percentage of the queries can benefit from the same clustering keys. So in other words, many queries select on or sort on the same few columns. So if our goal is primarily to reduce overall cost, then each cluster table should have a high ratio of queries to DML operation. So this typically means that the table is queried frequently and updated infrequently. If we want to cluster a table that experiences a lot of DML, then consider grouping DML statements in large and infrequent batches. And also remember, before choosing a cluster table, Snowflake strongly recommends that we test a representative set of queries on the table to establish some performance baselines. What is the reclustering? As DML operations are performed on clustered table, the data in the table might become less clustered. So periodic and regular reclustering of the table is required to maintain optimal clustering. So we said what are the DML operations? DML operations are insert, update, delete, merge, copy. So all performed in a cluster table. So during a reclustering, Snowflake uses the clustering key for a cluster table to reorganize the column data so that related records are relocated to the same micro-partition. So this DML operation deletes the affected records and reinserts them, grouped according to the clustering key. So reclustering in a Snowflake is automatic. Remember this, a reclustering in Snowflake is automatic, and we don't have to worry about the maintenance because Snowflake takes care of everything. So no maintenance is needed for reclustering. And however, for certain accounts, manual reclustering has been deprecated but is still allowed. We just discussed like how to define a clustering key for a table. Example, you want to define a clustering key for a table during the creation of table. So you can just say write a statement like create table, and in the table name just put your table name, let's say employee or salary department, and then cluster by expression and expression two. And then later you want to change the clustering key for a table. That means you forgot to define or you want to alter a table, then just run a statement alter table and then a table name and cluster by. And let's talk about automatic clustering. Automatic, automatic clustering is the Snowflake service that seamlessly and continually manage or reclustering as needed of cluster tables. So remember, after a cluster table is defined, reclustering does not necessarily start immediately. Snowflake only reclusters a cluster table if it will benefit from the operation. And we will also talk about what are the benefits of automatic clustering, that is in the next slide, or same slide, sorry. So the benefits of automatic clustering. So ease of maintenance. So automatic clustering eliminates the need for performing a lot of tasks, including monitoring the state of cluster table, and also designating warehouses in our account to use for reclustering. And as I mentioned, Snowflake performance automatic reclustering in the background, and we do not need to specify a warehouse to use. All we need to do is define a clustering key for each table, and Snowflake manages all future maintenance. And what is the other benefit? Full control. We can suspend and resume automatic clustering for a cluster table at any time using alter table and suspend, resume, recluster. While automatic clustering is suspended for a table, the table is never automatically reclustered, regardless of its clustering state, and therefore does not incur any related credit charges. We can also drop the clustering key on a cluster table at any time, which prevents all future reclustering on the table. And let's talk about the other two benefits. Let's talk about non-blocking DML. Automatic clustering is transparent and does not block DML statements issued against tables while they are being reclustered. And the last benefit is optimal efficiency. With automatic clustering, Snowflake internally manages the state of cluster table as well as the resources used for all automated clustering operations. Maybe you can ask me question like, what are the resources? Those resources are like example servers memory. And it allows Snowflake to dynamically allocate resources as needed, resulting in the most efficient and effective reclustering. And also, automatic clustering does not perform any unnecessary reclustering. Reclustering is triggered only when the table would benefit from the operation. What is manual reclustering? So we just talked about automatic reclustering, and we will automatic clustering. Now we will talk about manual reclustering. If manual reclustering is still available in our account, we can use the alter table command with a recluster class to manually recluster a cluster table at any time. The recluster clause instructs Snowflake to perform immediate reclustering of the specified table. Unlike automatic clustering, this DML operation requires a virtual warehouse in our account and locks the table for the duration of the operation. Also, after a period of significant DML activity on a cluster table that does not have automatic clustering enabled, a manual reclustering may need to be performed multiple times on the table to achieve the desired results. And we just talked about automatic clustering and reclustering and cluster tables, micro-partitions, and clustering keys. So now let's talk about the tables in Snowflake. So in addition to permanent tables, which is the default table type when creating tables, Snowflake supports defining tables as either temporary or transient. So these types of tables are especially useful for storing data that does not need to be maintained or maintained for extended periods of time. What are temporary tables? Snowflake supports creating temporary tables for storing non-permanent transitory data. So example, ETL data, session specific data. Temporary tables only exist within the session which they were created and persist only for the remainder of the session. And once you end the session, then you won't be able to access these temporary tables. As such, they are not visible to other users or others or session. So when you create a temporary table in your session, then other users, they may not access those temporary tables. Once the session ends, data stored in the table is purged completely from the system, and therefore it is not recoverable either by the user who created the table or Snowflake. So technically, the user is a owner. Even the owner or the user who created table, no one can record. Once the session ends, then you will lose the temporary tables. They are only for session. In addition to tables, Snowflake supports creating certain other database objects temporary, example stages. So all these objects follow same semantics. So they are session based, persisting only for the remainder of the session. So that we just talked about the temporary table. What are transient tables? So we talked about temporary tables. Now we'll talk about the transient tables. Snowflake supports creating transient tables that persist until explicitly dropped and are available to all users with the appropriate privileges. Transient tables are similar to permanent tables with the key difference that they do not have a fail-safe period. As a result, transient tables are specifically designed for transitory data that needs to be maintained beyond each session, but does not need the same level of data protection and recovery provided by permanent tables. And the data storage, let's talk about data storage usage for transient tables. Similar to permanent table, transient tables contribute to the overall storage charges that Snowflake bills our account. However, because transient tables do not utilize fail-safe, there are no fail-safe costs in Snowflake. Let's talk about other table type, the external table. In a typical table, the data is stored in the database. However, in an external table, the data is stored in files in an external stage. So external tables store file level metadata about data files such as file name, a version identifier, and related properties. So this enables querying data stored in files in an external stage as it were inside a database. External tables can access data stored in any format supported by copy into and a table name statement. So if you want to access data, then just run copy into and enter your table name. That is the statement. And remember, external tables are read-only purpose. Therefore, no DML operation can be performed on them. However, external tables can be used for query and join operation. Views can be created against the external table. And querying data stored external to the database is likely to be slower than querying native database table. However, materialized views based on external tables can improve query performance. And external tables reference data files located in a cloud storage. And what is the cloud storage? And Amazon S3 from AWS and Google Cloud Storage from Google Cloud, and also in Microsoft Azure there is a blob and also ADL. So remember, external tables store file level metadata about the data files such as the file path, a version identifier, and partitioning information. So that enables querying data stored in files in a data lake as if it were inside a database. So with these external tables, I think I covered all the uh, the the topics, including understanding tables and table structures in Snowflake. If you have any questions about understanding Snowflake table structures, or what are micro-partitions, or what is data clustering, if you have any questions about clustering keys, benefits of defining clustering key, or about cluster tables, or how to create a clustering key or alter clustering key, and also automatic clustering or manual reclustering. If you have any questions about any of these topics, please do not hesitate to post all your questions in the comment, and I will try to reply as soon as possible. If you like this video, please subscribe and share the channel. Thank you.